So in case one of your courses for this semester it's calculus, so this video I'm providing some overview about what you should have to expect about the calculus and what is it more about the calculus. So that's the essence behind this video. So what is calculus? So there are two types of mathematics. We have what you call pre-calculus mathematics and what you call calculus mathematics. So we have two types of mathematics. That is pre-calculus mathematics as well as the calculus mathematics. So what is pre-calculus mathematics? So pre-calculus mathematics is the study of the static mathematics, and while calculus mathematics is the study of the dynamic mathematics. So pre-calculus mathematics is the study of the static mathematics. You know, mathematics that does not change. In other words, a pre-calculus mathematics, a study that's actually a pre-calculus mathematics, a study that's actually studies about the situations that does not change, or the systems that remains constant, or the objects that does not change. And for instance, pre-calculus mathematics actually can help you to have the gradient of the straight line, of which a gradient of a straight line does not change. That is the static mathematics. And pre-calculus mathematics can also be able to help you to find the area of a rectangle. Let's say this is rectangle, of which given a typical rectangle, sides does not change. The side of let's say the length of this side and this side is the same, and the length of this side and this side is the same. So this is static mathematics, where the area of the rectangle is given as length times width. So this one remains the same, does not change for a given typical actually a rectangle. And pre-calculus mathematics can also be able to help you to have, let's say, the length of a straight line. So let's say if we have this point and also this point, you know, the distance between the 2 points can also be actually calculated using the distance formula. That is actually a pre-calculus mathematics. But how about if it is a curve? Do you think a pre-calculus mathematics can help you to have the length of this curve, let's say from here up to here, let's say over here? So pre-calculus mathematics cannot help you to have the length of that curve. Hence, there is a need of using a calculus that will help you to have actually the length of that particular curve. And also, pre-calculus mathematics cannot help you to have, let's say, the gradient of, let's say, this curve, because this curve is keep on changing. So in order to have the gradient, in other words, the gradient at this point is different with the gradient at this point, also different with the gradient at this point, and also this point, this point, this point, and this point as well. So in all aspects, these points are having their own gradients. So you cannot be able to determine those gradients using pre-calculus mathematics. There is a need of using a calculus for you to be able to have the gradient at a point in a curve. And also on the same case, a pre-calculus mathematics can tell you the direction of the object which is moving in a straight line path. Let's say we have two-dimension coordinate system. Let's say we have two-dimension coordinate system. Let's say this is the case. Let's say this is the y-axis and this is the x-axis. Now, assuming that there is an object moving, let's say, along x-axis, so you can be able to tell whether the object is moving towards this direction or the object is moving towards this direction. Likewise, if the object is moving along, let's say, a y-axis, let's say this is the case, you can be able to tell whether the object is moving towards this direction and also this direction using Pythagoras mathematics. But now, what if the object is moving in, let's say, a curvature or in a curve? Let's say this is the case. So now, how can you tell the direction of the object which is moving? Let's say it is at this point. So how can you tell the direction in which the object is moving? So we use actually Pythagoras mathematics in order to tell the direction of the object which is at this point. And this happens because at each and every point along the curve, direction changes. So we're going to see all these things, as far as Pythagoras is concerned. So Pythagoras is something that is very, very actually helpful, and basically in engineering actually disciplines, and as well as the economics actually disciplines. And all these actual disciplines uses what you call actually Pythagoras mathematics. And you should also have to understand that the Pythagoras mathematics can also be able to help you to study about the object which is moving at a constant acceleration. So if it happens that the object is moving at a constant acceleration, then you can be able to analyze that object using Pythagoras mathematics. And let's say we have the object, and let's say it is moving towards this direction from initial velocity given as u. And let's say it happens to move. Let's say this is the point A, and let's say this is the point B. And let's say after some time t, the object is at point B and covering, let's say, the distance given as s. And let's say at a point B, the object is having the final velocity given as actually v. So assuming that the object is moving at a constant, let's say, acceleration, then we can be able to analyze the motion of this object using actually Pythagoras mathematics. And from the fact that the object is moving at a constant acceleration, that is the static actually scenario you should have to understand. And Pythagoras mathematics will help you to actually analyze the motion of the object which is accelerating. So whenever the object is moving at a variable acceleration, then you can be able to analyze that object using Pythagoras mathematics, because that is the dynamic case. Mind you, Pythagoras is the study of dynamic mathematics that keeps on changing. And actually Pythagoras mathematics can help you to have the work done. And whenever, let's say this is the object of mass m, and let's say the object has been displaced to this point within the distance given as t. Now, from the concept of Pythagoras mathematics, provided the force being applied on the object is a constant force, then there is a work done due to the force being applied on the object, and the object happens to move to some distance t. Then the work done is given as the force times distance. Now, since the force being applied it's a constant force, then the Pythagoras mathematics is really working on this, because the force being applied it's a constant. So Pythagoras mathematics can help you to have the work done on the object, and whenever the force being applied is a constant force. And how about if the force being applied it's a variable force? So whenever the force being applied is a variable force, then we'll no longer use whenever the force being applied, let's say whenever the force being applied it's a variable force, then the work done will not be calculated using the same way we actually calculate whenever the force is constant. The work done will be calculated by considering the force that is being applied on the object being a variable actually force. So Pythagoras mathematics will help you to have the work done on the system and for the actually variable forces. And what are the examples of the variable forces? We have a friction force, and also we have it as spring forces. So precalculus mathematics will help you to analyze the object moving under the influence of a constant force, while calculus mathematics will also help you to analyze the object moving at the variable forces. So those are some things you have to understand about actually precalculus mathematics as well as the calculus mathematics. And precalculus mathematics can also be able to help you, let's say, to have the area of a definite shape. I would say the volume of a definite shapes. Let's say this is a case. You can be able to have the volume of this actual rectangle, the volume of this, let's say, circle, the volume of, let's say, this triangle. But precalculus mathematics, what if we have, let's say, this case? Let's say we have this case. So now, precalculus mathematics cannot help you to have the volume of this shape because the shape is not a definite shape. Because this curve is keep on changing. In other words, the curve is dynamic. So a calculus mathematics will help you to have the volume of this shape, while precalculus mathematics will help you to have the volume of these actual shapes. So a calculus mathematics is something very beautiful. Actually, it's something very beautiful for you to actually understand much about, and it also helps in the designing of some aspects in the engineering disciplines. And precalculus mathematics will help you to have, let's say, the surface area of a cylinder. Let's say this is a cylinder. So precalculus mathematics will help you to have the surface area of the cylinder. But now, what if we have a solid of revolution? What is a solid of revolution? No, a solid of revolution looks like this. It looks, let's say, like this. It's something that looks like the cylinder itself, but it's something different. Let's say we have it as this. You can have it in this way, and also, let's say, in this way as well. Let's say it will go like this. So this is what you call the solid of revolution. So now, how can we be able to have the surface area of this object? So we use actually a calculus mathematics in order to have that. And also you should have to understand that a precalculus mathematics, let's say we have the two-dimensional coordinate system. And let's say we have the graph like that. And I would say we also have, let's say, two-dimensional coordinate system. Let's say that is the case. Now, let's say I would like to find the area under the graph. So now let's say we have this case. This graph, starts from here, and it is ending here. What is the area under the actually a graph? So you can see that we can be able to divide the region into the definite shapes. And for instance, we can have this. This is rectangle triangle, and this is the rectangle. So you can be able to have the area of the rectangle triangle and also the area of the rectangle. and thereafter you'll be able to sum them. But now, what if we have this case? So now, how can you be able to have the area under the curve? And for this case, now this curve, it's dynamic curve. It keeps on changing at each and every point. So the area under, actually the region under the curve is not definite. Actually, it's not definite a region, because the region is keep on changing. At this point we have it in this way, at this point we have it in this way, and also this way as well. So you cannot be able to use precalculus mathematics in order to have the area under this curve. They actually, hence we use actually calculus in order to have the area under the curve. In other words, we only use the calculus mathematics in order to have the area under the curve. So keep that in actually in mind. So there are several applications you should have to understand about a calculus mathematics. So it's something that you should be able to, let's say, understand much about, and that you grade as well. So how should we move, or how do we move from precalculus mathematics to calculus mathematics? Now, let's say this is precalculus mathematics, and let's say we are to move to calculus mathematics. Let's say this is a calculus mathematics. Now, there is a bridge that connects the two. Actually, there is a bridge that connects the two. How should we be able to transform from precalculus mathematics to calculus mathematics? How should we move from static mathematics to dynamic mathematics? And the bridge that connects the two is said to be the limit process. Is what you call the limit process. So a limit process is the machine or the bridge that helps us to translate from precalculus mathematics to calculus mathematics. So no wonder when you'll be looking about the calculus concept itself, we'll start looking at the process, actually a limiting process, or we call it as the limiting machine, in order for us to transform from precalculus mathematics to calculus mathematics. So the first chapter in calculus, it's what you call the limits, and that will really help you to transform from precalculus mathematics to calculus mathematics. So that's how you should have to understand about the calculus mathematics as well as the precalculus mathematics. So calculus mathematics is the study of the dynamic mathematics, while precalculus mathematics is the study of the static mathematics. But how do we move from precalculus to calculus? We use what you call the limiting process, or we call it as a limiting machine. So the first topic you should have to understand about, it's that of the limit processes that will help you to translate from precalculus to calculus mathematics. So that's how you should have to prepare about calculus, as you'll be transforming from precalculus mathematics to calculus mathematics. So thank you, as you'll be studying actually your calculus mathematics. So in the comment section below, I'd like you to give me some of the examples, some of the areas in which the calculus mathematics can be actually used, apart from the ones that I have actually specified in the actually video. Thank you.